MCQ from Semiconductors, NEST 2018, question 63. Consider the circuit with an ideal PN diode as shown. Let Vp be the voltage applied at the terminal P. The equivalent resistance between the terminals P and Q is R1 when Vp is plus 5.0 volt and R2 when Vp is negative 5.0 volt. Then R1 and R2 equal to 5R by 3, 3R by 5, 3R by 5, 5R by 3, 2R by 3, 5R by 3, 5R by 3, 2R by 3. Okay. Now here is, in this problem, there is a simple fact regarding diodes that we have to use. Okay. And what is that? What is that? When the diode is in forward bias, it acts as closed switch. And because they are saying that the diode is ideal, resistance of the diode is 0 in forward bias condition. Okay, in forward bias condition. And how about the situation with the reverse bias? If VA is less than VB, then the diode acts as an open switch, which means resistance of the diode is infinite. So no current can pass through it. Raise your hands if you have understood this. Okay, let's now go to the first case, VP 5.0 volts. Okay, now this means the diode will clearly act as a closed switch. So what will be the equivalent circuit? What will be the equivalent circuit? Look here. This resistance is there. This resistance will be there. Now pay attention. Pay attention. This needs to be collapsed. Okay, so this point is now our Q, right? Because the diode is forward bias, so it's like closed switch. So if I show that point Q here, then this will directly go to Q. Okay, this will directly go to Q. Now look, this point is now equivalent to Q. This point is equivalent to Q, which means this resistance will now be connected to Q, and so is this. So what I need to do is, I need to draw a parallel combination of those two resistors before I join them to Q. And what is this R? The R that I have encircled there in red color is this R. And then this is our capital T. Have you understood this combination? We need to collapse this point to this point. Raise your hands if you understood that. Yes? Okay. Now can we find the equivalent resistance? Of course. For this, the resistance will be R by 2, right? Because they are in parallel, 1 upon R plus 1 upon R, 2 upon R. Take the reciprocal out. R plus that, R plus that, 3R by 2. So 3R by 2 and the upper R, they are in parallel. So let's take 1 upon R plus 2 by 3R. That is 3 plus 2 by 3R. That is 5 by 3R. So R1 will be 3R by 5. And we have got the option as B because only R1 in B has 3R by 5. Everywhere else we have different options. Okay, different. But suppose we also insist on finding, with Vp equal to negative 5.0. How can we do that? Pay attention. Okay, Vp is suppose now negative 5.0 volts. Okay, negative 5.0 volts. How to handle that situation now? How to handle that situation? Okay, see, look, to handle that situation, we start with usual P. We start with usual P. But now that diode has become reverse biased because its N side is at a higher potential than its P side. P side. Okay, which means this R is now as good as an open circuit. Do you realize that? This R is there. Okay, there is no connection now because between this point and Q. Okay, because of this and this resistance R. Okay, this is also now like an open circuit because that resistance is infinite. There is no path that is taking them to Q. There is only this path. Okay, raise your hands if you understand this. But they are connected. They are connected to each other, so we must join them here. It's not that we will just leave them as they are. No. Got it? So this is now going to be our equivalent combination. Got it? So let us now consider that R plus the encircled R, because they are in series. That means that their resistance is 2R. That 2R is in parallel with this R, the one at the bottom. So 1 upon R plus 1 upon 2R. 2 upon 2R, 1 upon 2R. So 3 upon 2R. Its reciprocal is 2R by 3. Then we have got this R, which is in series with that. So 2R by 3 plus R, that will be 5R by 3. And that's the R term. That's all. Okay, 5R by 3. Fine. Have you understood this? Simple application, can come in IIT. Okay, because now they have covered both the series parallel combination and the behavior of the diode. Okay, got it?